This is a uniform distribution problem. Arrival time of a bus. A bus arrives to a bus station every 12 minutes. So every 12 minutes, on average, every 12 minutes, there is a bus arriving to a bus station. We would like to investigate the length in time a commuter must wait for a bus to arrive. The waiting time follows uniform distribution. All right, I see a word uniform distribution. And then other than this, I also see every 12 minutes. Every 12 minutes. So what does that mean? Every 12 minutes, okay, let's bring it here. Every 12 minutes, so that tells me one thing, that the minimum is 0 and then the maximum is equals to 12 minutes. Okay, that's what I get from that. And then the waiting time follows uniform distribution. I can say this is a continuous random variable x. This variable represents the waiting time, follows uniform distribution, and then a is equals to 0, and then b is equals to 12. That tells me that the PDF probability density function 1 over b minus a, that is equals to 1 over 12 minus 0, big number minus small number, that is equals to 1 over 12. And then we can draw a graph. I have y-axis, x-axis, this is x, and then this is a y, this is from 0 to 12, this is a 0, and then this is a 12, so let's put a 12 right here, and then this is the height of the rectangle, from 0 to 12. And then what is this horizontal line represent? This horizontal line represents f of x equals to 1 over 12. And then the height of this rectangle is 1 over 12, but the dashed line is not part of the graph. How do you know that this PDF, this probability density function, PDF, probability density function, is correct? All you need to do is you need to verify that the total area, okay, let me move this away, and then the total area of a rectangle. What's the total area of a rectangle? The base. The base is big number minus small number. This is the base. And then you multiply the height. That is equals to 1. So this total area is equals to 1. This total area is equals to 1. And then what else can we do? Other than this, we are not answering any probability questions yet. We got a setup, we got a graph, and then what else you can do is you can find the expected value of random variable x. This is a uniform distribution. Then we do a plus b divided by 2, which is 0 plus 12 divided by 2. This is equals to 6 minutes. What is 6 minutes mean? 6 minutes means, that means on average, you have to wait 6 minutes to see a bus arriving. And then the variance. The variance, this is a 1 over 12. So I need to remind you that this 1 over 12 is part of the formula. It is always 1 over 12. Always 1 over 12. Okay, and then we have 1 over 12. The maximum is 12. The minimum is 0. And then square 12 squared divided by 12. So let me move that away. That is equals to 12, right? And then what is the unit? The unit is minutes square, because you square the minutes right here. And then variance makes no is meaningless because the unit is square. That's why we need a standard deviation. The standard deviation is the square root of variance, which is the square root of 12. That is approximately equals to 3.5 minutes. So we have the expected value, the variance, and standard deviation. How do we use these numbers? You can say on average, you have to wait 6 minutes, and then to create a better estimation, you can say I will do an interval estimate plus or minus 3.5. And then 6 minus 3.5 is 2.5 minutes. And then 6 plus 3.5 is 9.5 minutes. So that means when you want to see a bus, right? On average, you have to wait around 2.5 to 9.5 minutes. So by just recognize that this is a uniform distribution, we can do all of this. And then the next video, I will answer some probability questions. I recommend you to draw a good graph because we will use this graph to answer each probability question. All right, I will see you in the next video.